Hey guys, Mr. Backerberg here. In this video we're going to look at relations that are defined parametrically. Now we're used to defining equations and functions in terms of x and y ordered pairs. But when we're defining things parametrically, we're actually going to introduce another variable, which is going to be t, and that's called the parameter. And what we're actually going to do is we're going to define each one of our variables individually using this t parameter. So we're still thinking about things in terms of x's and y's, but here's what I want to do first. For our x's, I want that to be defined by the equation t plus 1. And for my y's, I want that to be defined by the equation t squared plus 2t. So each one of our variables is being defined by its own equation using this t parameter. So the first thing we're going to do is we're going to take this information and we're going to make a table of values. So we're going to look at a few different t values going from -3 up to +3, and what we want to do is we want to find our x and y values that are associated with each one of those t values. So what we're going to do to find our x's, we're just going to take these t values and plug them into our x equation for the t. So like if we take the -3 and plug it in, -3 plus 1 is -2. And if we take the -2 and plug it in, add 1 to that, we're going to get -1. So then our next one should be 0, and then 1, and then 2, and then 3, and then 4. And now we're going to do the exact same thing with our y values. We're going to take those t values and plug them in. So first we're going to have to take t and square it, and then we're going to add 2 times t on there. So like if we plug in -3, -3 squared is 9, and 2 times -3 is -6. And if we add those together, then we're going to get 3. And then I can go through and plug in my next t value. So -2 squared is 4, and if I take 2 times -2, that's going to be -4, so when I add those together, we're going to get 0. And I can run through the rest of my t values, plugging those in. Now these do still create ordered pairs because we have an x and a y value. So here where we have -2 and 3, that really represents the ordered pair, -2, 3. And if we work our way down the line, the -1, 0 would be the next point, and we can go and build all of these ordered pairs based on the information that we have from our table. So now that we have all of these ordered pairs, we can take these and plot them out on an x and y grid. So at -2 we're up at 3, so I'm going to plot that point out, and then at -1 we're at 0, then at 0 we're down at -1, at 1 we're back to 0, and then at 2 we are up at 3. And then if we connect these dots, we can see that we're getting a parabola shape for our graph. And as we look at the graph of our parabola, this would pass the vertical line test, so it definitely is a function. Now the last thing I want to do with this example is go back and look at how we defined our x and y variables, and we're going to look to find an algebraic relationship between x and y. This is called removing the parameter, so what we're going to be doing is getting rid of the t value. In order to do that, the first thing I need to do is I'm going to look at my x equation, and I want to solve this to get t alone. So what I would need to do is subtract this 1 over to the other side, so we would get t is equal to x minus 1. And now what we're going to do is in our y equation, where we have our t variables, we're going to take what we know about t, since it's x minus 1, and we're going to plug that in. So we would get the equation y equals, now we're getting rid of the t in here, and we're plugging in the x minus 1, so we get x minus 1 squared plus 2 times x minus 1. Now here, when we're taking x minus 1 and squaring it, we're going to have to take x minus 1 times another x minus 1 and FOIL that out. So when we do that, we should get x squared minus 2x plus 1. And then on the end, if I distribute my 2, I'm going to get plus 2x minus 2. And then I'm going to combine my like terms. I don't have anything to combine with the x squared, so that's going to stay. The -2x is going to cancel out with the regular 2x. And if I combine the 1 with the -2, then we're going to get minus 1 on the end. So x and y are related to each other by the equation y equals x squared minus 1. And algebraically, this would represent y as a function of x. Now we're going to look at another example here, but this time we're going to use our graphing calculator to help us out. So we're going to define our x as t squared plus 2t, and this time we're going to define our y as t plus 1. And now I'm going to fire up my calculator. Now, in order to graph things out parametrically on our calculator, the first thing we're going to have to do is change what mode we're in. So I'm going to hit the mode button, and then if I look on the fifth option down, right now my calculator is in function mode, but I want to switch it into parametric mode. So I'm going to arrow down there, I'm going to arrow over to parametric and hit enter. Now when I hit my y equals button, the options are going to look a little bit differently. It's going to give me an option for defining my x, and it's going to give me an option for defining my y. So remember, our x was defined by t squared plus 2t, and my y was defined by t plus 1. So I can just type both of those in there, and then if we want to look at a table, we're going to hit second graph, and it'll bring up a table of our values. So just like we had when we were doing this by hand, it's got a t column for those t values, and then it's got an x column and a y column. And again, we could think about building ordered pairs with these. So this would be the ordered pair 0, 1, this would be 3, 2, this would be 8, 3. Now before we graph this one out, I want to take a look at the window in here. And I'm going to adjust my window a little bit just so when we graph it out, we get a nice picture of what we're looking at. So for the t minimum value, I'm going to put -4 in there. For my t maximum value, I'm going to put 2. For the t step, I'm just going to put 0.1. For my x minimum, I want that to be -5. And my x maximum, I'm going to make +5. And for my y minimum and my y maximum, I'm going to go -5 to 5 as well. And now I'm going to graph this out. Now when we graph this one out, we can see that we get a sideways parabola. So this will not pass the vertical line test. So this one does not represent a function. Now we're going to go back to our equations here, and we're going to look at finding a relationship between x and y. So we're going to remove the parameter. On this one, because we have a lot of things happening with our x equation, I think it's actually going to be easier to solve our y equation to get t alone. So I'm going to subtract that 1 over to the other side. So I'll get t equals y minus 1. And then I'm going to take that stuff and plug it into my x equation for my t variables. So when I do this, I get x equals y minus 1 squared plus 2 times y minus 1. Now when I square this y minus 1, I have to take y minus 1 times another y minus 1 and FOIL that out. So I'm going to get y squared minus 2y plus 1. And then if I distribute the 2 on the end, I'll get plus 2y minus 2. And then if I look to combine like terms, the negative 2y and the positive 2y are going to cancel each other out. The 1 and the negative 2 will combine to get -1. So we're going to get x equals y squared minus 1. And then if I wanted to solve to try to get y alone, I would add this 1 over to the other side. So I would get y squared equals x plus 1. And then to get rid of the squared power on the y, I need to square root both sides. But when I do that on the right hand side, when we square root this, we have to remember to put our plus and our minus in front of that. So we're going to get y equals plus or minus the square root of x plus 1. And the problem with this equation is with that plus and the minus in the front. When we plug in an x value, we're going to get back 2 different y value answers. So algebraically, that makes this one not a function. That's going to be it for this video. Thanks for watching.